Hello, my name is Antonio Selma, and I'm gonna talk a little bit about scheduling problems. I'm gonna give you what is a definition of a scheduling problem and main characteristics so you can understand what is this kind of problem about. I'm gonna give you some examples so you can understand better what are these problems and so what is the motivation of this problem. And then I solve one scheduling problem, one of the basics, and then at the end just give you the references. So basically, scheduling problems consist of organizing in time execution tasks that share a finite set of resources. So basically, it consists of allocating our known activity to limited resources and time. The optimization is usually related to the cost and the total execution time of the problem. So we need to know what are we working for and what is our limitation. Combine that to get a good solution. The motivation for this kind of problem is that they are very complex, so a lot of people are interested in solving them, and also they can be applied to many real-life situations. And the way to solve this problem is with mathematical methods, or either way, artificial intelligence using computer programming and all that stuff. These are some examples of a scheduling problem. Plan de land was set of aircraft when the goal of this is to minimize the deviation of the flights and maximize the safety condition of the plane. Another one would be routing of data back through the communication lines, for example, Wi-Fi stuff. The goal of this, we work on a problem to maximize the use of network and also to minimize the arrival time of the messages through the communication with people or whatever. And another one is manufacture of wafers of semiconductor circuit. The goal of this would be to maximize the use of the machines and also to minimize the runtime of the processor. And here is the problem I work on. So we have a small factory manufacturing two different types of robots, P1 and P2 robots. The P1 robots are made with kilograms of carbon fiber and 8 kilograms of aluminum. The P2 with 1 kilogram of carbon fiber and the same, 8 kilograms of aluminum. So P1 unit price is $8 and P2 is $10. And also the whole material that this factory can handle up with per day is 10 kilograms of carbon fiber and 120 aluminum. And our goal in this problem is basically to maximize this price so we can obtain the best benefits for the factory. And this is the way to prepare this problem. So the first thing we need to know is to allocate our sources. So we have here the carbon fiber, we have the aluminum, and then we have P1 and P2, the two different kinds of product, and then the total materials that we have in the problem. So basically this is optimization. We use three different equations to solve this problem, one for the carbon fiber, one for the aluminum, and then one for the price. This will be a representation of the three equations. This is the area of interest. This is where our solution is gonna be according to our equation. So once we solve the equation, we get a value for X, the P1 robot, we get a value for Y, the P2 robots. Then we solve it for the price, and we can check that we get in the maximum price per day would be 130, which is the maximum. We can check for another two different values. We can see for calling the Y, so the P2 10 or the maximum will be 15 for the X, but we see that the values are less than 130, and this would be the point where our solution would be. That's it. This is just reference I use from two doctoral theses from Spain, from my country, and then one more from Dartmouth University in electrical. This is where our information I took and the problem also. And that's it. If you have any question about the problem or anything,